Take a look at this diagram comparing two spheres of water. On the left is every drop of liquid in Earth's oceans. On the right is the estimated volume of water trapped inside Jupiter's moon, Europa. It contains more than twice as much liquid water as our entire planet. From the outside, the moon looks completely frozen. The surface is a chaotic web of scars and ridges, a thick ice shell appearing entirely dead. Yet that hidden ocean makes this moon one of the most compelling targets in the solar system. Here on Earth, wherever we find liquid water, we find life. If that rule holds true across the universe, Europa is our best local candidate for biology. Getting to that water involves navigating a gauntlet of extremes. Europa sits 1.8 billion miles away, locked in the middle of Jupiter's intense radiation belts. And even if you survive the neighborhood, that subterranean ocean is buried beneath an ice sheet that is miles thick. The challenge is to determine if this buried saltwater ocean has the right chemical ingredients and energy sources to sustain living organisms, and to do it without ever touching the surface. This is NASA's Europa Clipper. It is the largest spacecraft the agency has ever developed for a planetary mission. Because Jupiter is so far from the sun, the light is incredibly faint. To generate enough power, the Clipper's solar arrays span more than 100 feet, roughly the length of a basketball court. The mission officially began on October 14, 2024, when the spacecraft lifted off from Kennedy Space Center atop a Falcon Heavy rocket. Beyond the vast distance, the spacecraft faces a lethal environment surrounding Jupiter. The planet's magnetic field acts like a massive particle accelerator, bombarding the moon with radiation equivalent to millions of chest X-rays. To protect the sensitive electronics, engineers sealed the spacecraft's computer brain inside a specialized aluminum-zinc alloy vault. But even a metal vault cannot withstand that environment forever. Instead of orbiting Europa directly and soaking up constant radiation, the Clipper will orbit Jupiter in a wide ellipse. It will dip in for 49 quick, close proximity passes of the moon, gathering data and then speeding back out to safer space. It will take the Clippers 6 years just to reach Jupiter's orbit. If you're learning something new, please hit like and subscribe. Now, let's look at how this probe will actually see through the ice. Surviving the 1.8 billion mile journey and the radiation are only the prerequisites. The actual mission depends entirely on whether the instruments on board can peer through miles of solid ice. The first major tool is the Europa Imaging System, or EIS. EIS consists of 2 visible light cameras designed to map 90% of Europa's surface in high-resolution, 3-dimensional color. During close flybys, these cameras will zoom in to capture details as small as half a meter across. They will be hunting for active thermal vents, or giant plumes spewing water from the subsurface ocean directly into the vacuum of space. To look beneath the surface, the spacecraft relies on an ice-penetrating radar called REASON. REASON stands for Radar for Europa Assessment and Sounding, Ocean to Near Surface. This diagram shows exactly how the radar works. As the spacecraft flies overhead, it will blast high and very high-frequency radio waves down into the moon. These waves pass right through the solid ice until they hit the denser liquid ocean below, which reflects them back. Because we know the speed at which radio waves travel through ice, scientists can measure exactly how long it takes for the signal to bounce back to the spacecraft. This allows them to calculate the precise thickness of the ice shell, which is estimated to be up to 18 miles deep. The radar will also catch signals that bounce back early, mapping out isolated pockets of liquid water trapped completely inside the frozen crust. By layering the ultra-high-resolution surface maps over the deep radar scans, scientists will build a complete 3D cross-section of an alien world. They will survey the ocean's depth and structure without a single piece of hardware ever touching the ground. The Clipper's goal is to test for habitability rather than search for alien organisms. The mission will confirm the presence of water, chemistry, and energy, the baseline requirements for life as we know it. By September 2034, the spacecraft will have completed its 49 flybys, mapping the entire moon and exhausting its operational lifespan. At that point, NASA will execute a strict planetary protection protocol. To guarantee the dead probe never drifts into Europa and contaminates a potentially habitable ocean with Earth microbes, engineers will intentionally destroy it. They will steer the Clipper away from its target and crash it into the surface of a different Jovian moon, Ganymede, keeping Europa's ecosystem entirely pristine. The Clipper's fiery sacrifice will finally give us an answer. We will know if Earth is the only ocean world capable of harboring life, or if we need to start building a submarine for our next trip to Jupiter.